name is Gilbert Barron. My topic is raise or flood-proof HVAC equipment. In an average year, floods cause over $3 billion in property damage. A large proportion of flood damage is incurred by components of building utility systems, including HVAC equipment. This topic is of special interest to local officials, building owners, architects, engineers, builders, and contractors. In this presentation, you will learn how to design and construct building utility systems for residential structures and comply with the National Flood Insurance Program. Some key objectives: how to comply with NFIP requirements in a special flood hazard area. When is it appropriate to raise or elevate HVAC equipment? How to flood-proof HVAC equipment as an alternative mitigation measure. The NFIP requires that the HVAC system located in a special flood hazard area be designed so that floodwaters cannot infiltrate or accumulate within any component. This is done by 1. Elevation, which refers to the location of the component above the DFE, and 2. Component protection or dry floodproofing, which refers to the implementation of design techniques that protect a component located below the DFE. In this table shown here, you will see that mitigation methods of elevation and component protection are recommended in zones A and B, except for notice that in zone V, component protection is not allowed. In this diagram, you will see typical components of an HVAC system. This drawing has two HVAC systems, one in the basement or garage here, and one in the attic. Typically, the attic is more desirable for new and substantially improved construction. You will see that on the outside, there is a compressor unit, and on the inside, there is a furnace with number 3 here is supply and return ducts, and right here number 5 are the lateral ducts and registers, which are typical. Some main issues in outdoor HVAC components is presented by floodwaters, inundation, velocity flow, and debris impact. Also, short circuit and mechanical equipment would fail to operate and may be torn away. Most of the metal components would eventually corrode and deteriorate, especially in areas inundated by floodwaters containing salt. Outdoor equipment, elevated platforms. Equipment should be located on elevated platforms that cantilever out from the structure. Also above the DFE to avoid damage from breaking waves. The platform should be designed to resist wind and other forces as specified by local building codes. In coastal areas, anchors and straps should be stainless steel or hot dip galvanized to resist salt spray and corrosion. Outdoor components can also be elevated on pedestals or platforms. Notice that when sitting on pedestals, on piles, the piles should be supported and extend below the expected depths of erosion, scour, and frost. These equipment should also be located on the landward side in coastal areas or downstream side and riverine areas of homes to minimize risk from flood-borne debris impact. Indoor HVAC components should be elevated on a pad or a platform. This one can be made out of concrete or wood platforms that meet code requirements. Notice that the equipment is above the DFE on the platform and is properly secured. Right here is shown the furnace and the boiler, water heater. Dry floodproofing may be an option if the residence is not new construction or undergoing substantial improvements. Watertight walls are generally used when construction of pedestals is not feasible. These walls are made to resist hydrostatic and buoyancy forces. Provisions should be made to address seepage, because these watertight walls aren't 100% watertight all the time. So a sump pump should be incorporated. Also, it is recommended that a standby power source, such as generator, is nearby. Notice that in the details of this watertight wall, the joints are sealed with a watertight seal made of neoprene or effective seal gasket. Like mitigating primary components, the most effective strategy for mitigating secondary components is to elevate them, preferably above the flood protection level. When elevating ducts, NFIP does not recommend ducts located below DFE, because if ductwork must be installed below the DFE, it should be minimized as much as possible. The material used for the ducts must be impermeable and watertight, such as welded seamless ductwork or large diameter PVC. Final configuration of the duct systems should be evaluated by an HVAC contractor with assistance of the designer. Secondary distribution components are all components and electrical components should be located above the DFE. This is because they're typically very expensive and particularly susceptible to damage. Luckily, these components can easily be relocated above the DFE. Water and fuel piping associated with HVAC systems must be properly protected from damage during flooding. PVC piping generally more susceptible to impact and breakage, so copper and galvanized metal piping is better suited for use in flood-prone areas. Key takeaways are elevating HVAC components above DFE is the best option. Elevation of components is the only option in coastal V zones per NFIP. All components must be properly secured to resist forces according to code, including wind, seismic, buoyancy. This concludes my presentation. Thank you for listening.